There is this linear circuit, and we want to prove that R1 parallel R2 and then parallel R3 equals R1 parallel R2 parallel R3. We want to prove this relationship, and we want to write an explicit formula for the total resistance in the circuit. So we start to write down the proof. R1 parallel R2 and then parallel R3. R1 parallel R2 is going to be R1 R2. The product of the values of the resistors goes into the numerator, and in the denominator we have the sum of the values of the resistors, and then parallel R3. Now we do the same approach here, so it's going to be R1 R2 over R1 plus R2 times R3 over R1 R2 over R1 plus R2 plus R3. And then we can times the both quantities here by R1 plus R2 to get a more elegant expression. So in the numerator we will have R1, R2, R3, and in the denominator we will have R1, R2 plus R3 brackets R1, R2. And we can expand this reads as R1, R2, R3. We have the product in the numerator of the three values of the resistors over R1, R2 plus R2, R3 plus R1, R3. Now let's go the other way around. Let's take R1 parallel R2 parallel R3. That's gonna be R1 parallel R2 times R3 over R2 plus R3, and then that is going to be R1 times this quantity here, R2 R3 over R2 plus R3 over R1 plus R2 R3 over R2 plus R3. We can get a more elegant expression for this one by multiplying by this fraction R2 plus R3 over R2 plus R3. So the numerator is going to become R1, R2, R3. And in the denominator we have R1 times R2 plus R3 in brackets plus R2, R3. So that one gives you in the numerator R1, R2, R3 over R1, R2 plus R1, R3 plus R2, R3. And you can see that the formulas are identical. So we have R1 parallel R2 parallel R3 equals R1 parallel R2 parallel R3, and that's gonna be R1 R2 R3 over R1 R2 plus R2 R3 plus R1 R3. So in this case, doesn't matter if I start working from the outside, from outer to the inner, or from inner to the outer, I'm going to get the same result. Of course, this R1, R2, R3 are different from 0, which means I mean the sum R1, R2 plus R2, R3 plus R1, R3 should be different from 0. This sum should be different from 0. So let's call it capital R, the total resistance here, and is a function of 3 variables, R1, R2 and R3. This is a function of 3 variables in this case, and this is the formula. This circuit is very popular in the literature. Is a linear circuit. You have a voltage source, and then you can have this R1, R2, R3 in parallel, and then you can have a load. A load can be a bulb or a LED or anything like that. So that's the whole point of this video.